Good morning. So we're going to investigate what happens when we transform the sine function in this exercise. Follow the link which I've given to you in the class notes. This is one of those online GeoGebra worksheets, and the first thing to do is set it up as follows. So this green slider here is 0. This one here one and 0. Can't actually read that. What does that say? Oh, it's at 1. Right, okay. Now a little quick tip for you. If you hold the mouse on the slider and then press the cursor keys, the arrow keys, left and right, you can actually increment just one increment at a time. Okay, so what we're going to do is, first thing to do is to copy down this function here. So g of x equals 1 sine, bracket 1x minus 0 plus 0. Copy that down into your notebook and simplify it as fully as possible. Pause this video until you've done that. Hopefully you managed to simplify it. Okay, if we have 1 times sine, we just write sine. 1 times x, we just write x. Plus 0, it's just x. Plus 0 is just x. Okay, so this is the basic sine function, g of x or equals sine of x. Okay, now we're going to investigate what happens when we do some transformations. The first one I want you to do is to change this slider here. Okay, so hold your mouse on it. Whoops, it's adjusting the wrong one. Hold on. So we're going to change the vertical amplitude first. Now, look at the function, look which bit is changing. Okay, it's this multiplication at the front here is changing, and look at how it's affecting the graph of the function. Now, the amplitude of the function is the vertical height. Okay, it's the maximum vertical height that the function gets away from its middle line. Okay, if you can imagine there's a middle line running through the function, we call that the principal axis. The amplitude is the maximum height achieved away from the principal axis. It's not always the distance from the x-axis, and it's not always the y-coordinate. It is in this case though, because the maximum y-coordinate here is 2, and the minimum y-coordinate is -2. Okay, anyway, pause the video now and then explore these transformations a bit more. So try a few more different values for this. Okay, and then pause the video and see if you can explain why that happens. Okay, so justify why we see that. So g of x is the y-coordinate basically, isn't it? And if we put a 3 in front of it, like we've got here, this is the simplified version of that expression. If we put a 3 in front of the function, we're just multiplying all the y-coordinates by 3. Now this is the original sine function, which has y-coordinates of +1 to -1 and all values in between, and all we're doing is we're just multiplying those y-coordinates by 3. So here it's about 1/3, here it's about 1. Okay, so we're just multiplying the vertical distance away from this principal axis. I'm going to write that word here. This is the principal axis for the function, and it's the line that runs through the center of the function. Okay, now let's have a look at another one. We're going to take that back to 1. Let's take the amplitude back to 1. And now let's investigate what happens with vertical shift. Okay, so we were just talking about the principal axis. Now watch what happens as we change the vertical shift. So you need to watch the slider and then watch the function as well over here, and look at the graph as well. So that's when the vertical shift is 1. What has changed about the function? What just changed as we went from 0, look at the function, to 1 for the vertical shift? Okay, see if you can play around with this for a few minutes, okay, and then see if you can explain why we're seeing that. Pause the video until you can explain it. So in this case here, this is the original sine function, and the blue function has been transformed. This time we've added 3. So g of x is 1 times sine of x plus 3. And what you'll notice is that all of these distances here, the vertical distance between those two functions, is always 3 units. Okay, so the function, this black function, has actually moved up by 3 units to get to where the blue function is. We could also look at negative values, and in those cases the function is translated downwards. So what we're looking at here is a vertical translation. Okay, vertical translation, and this is a case of f of x being transformed into f of x plus a. Okay. So now we're going to have a look at the effect of a different, these are called parameters, by the way. These numbers in the function are called parameters. So there's a parameter at the front, there's one in front of the x, this is another one, the subtract 0, and then a plus 0. Let's explore horizontal shift. Okay, so we're going to play around with this slider now. Can you see what effect that is having on the sine function? Pause the video. Okay, look at how the function itself changes. Look at how the graph moves, and then see if you can explain why that is, and see if you can relate it to this kind of thinking which we met on the My iMaths website when we studied transformations of graphs. Pause now, please. This one is a little bit more difficult to explain. Let's start by just simplifying this expression a little bit. So we've got 1 times sine of x minus 4. Okay, now notice that this sine function is beginning here at the origin, 0, 0. This one is beginning at 0, 4. So hopefully you can see that the effect of that is a horizontal translation. And it's exactly 4 units in the horizontal direction. Okay, so as we go from the crest of the wave here to the crest of this wave here, that's 4 units. This trough here and this trough here, or minimum points, they also have a distance between them of 4 units. Okay, so the black function is translated 4 units to the right by this here. Now this may remind you of this scenario in My iMaths when we saw this, when f of x was transformed to f of x minus a. This actually gave us a horizontal translation of 4 units to the right. And this was one of those weird ones where, there we go, horizontal movement, vertical movement. And this was one of those weird ones where it was tempting to put a plus there, but it was the wrong thing to do. Okay, if it's f of x minus a, so what we're doing is we're subtracting from the input to the function before we put the value of x into the function. Okay, so if I just do this again, so we've got x minus 4, so we're subtracting from the input to the function x before it goes into the sine function like that. Okay, and that's what makes it move 4 to the right. If it were a plus there, then it would have moved to the left. Okay. Alright, let's have a look at the last transformation now. We're going to explore, let's just return these values to normal. Okay. And we're going to look at horizontal stretching or shrinking. So play around with this slider now. Oops, there we can see the effect of stretching and compression. Stretching and compression. You could also call it dilation and shrinking. So stop the video, see if you can explain why this is happening with reference to the My iMaths transformations, and then start the video again once you've had a go at explaining it in your own words. Okay? The distance it takes this function to go from the start here to a maximum, to a minimum, and then back to the same position here, this is called one wavelength. Okay, one wavelength, or you can call it one period. If you simplify this function here, we end up with g of x equals to sine of 2x. So what we've done is we've doubled the input to the function, the x, before it goes into the sine function, okay, which has had the effect of this is halved the wavelength, or halved the period. Okay, so the period is now half what it was before. Here the period is 2 pi. Okay, that point there. Here the period is just 1 pi. Okay, so you can see the period has been divided by 2 if we multiply the input by 2. Okay, now why does that happen? This one's actually quite hard to explain. Hopefully you all remember this screen here on the My iMaths Transforming Graphs lesson, and the situation we're looking at here where we're multiplying the input to the sine function. Lost a bit of it there, but what we're looking at is this one here, f of ax, which causes a stretch of a scale factor 1 over a in the horizontal direction. Okay, so what we've got here is, this is like f of x being transformed to f of ax, which is a stretch scale factor equal to 1 over a in the x direction, or in the horizontal direction. Okay, so that explains why sine of 2x has a wavelength which is half as much, because we've stretched it by a scale factor of 1 over 2. In other words, we've compressed it by a scale factor of 2. Okay, there's only a couple more of investigative transformations to look at now. So let's return this one back to 1 again. Okay, so we're dealing with the basic sine function again. Let's have a look what happens if we reflect about the y-axis. Now, you can see the effect. It's as if there was a mirror line running down the y-axis, an axis of symmetry. And look at the effect on the function. Keep your eye here as I do the reflection again. So what actually happened there was simply, looks a bit like a moustache, doesn't it? Okay, or even a pair of lips. So stop the video, see if you can explain what we're seeing there and why it happens. This function would simplify to g of x equals sine of minus x. Okay, so what are we doing? We're reversing the sign of the input, changing the sign before we put it into the sine function. Okay, so here, when this is pi radians, we get a maximum. And the reason for that is because sine of pi equals 1. But in this function here, when we put pi into the function, g of pi, we would get sine of minus pi. Okay, so instead of seeing pi, our function's actually seeing minus pi. And what that does is it has the effect of reflecting over in the y-axis. Okay, so what we're looking at in terms of the My iMaths transformations, okay, well we can't actually see it on this lesson here, but what's happening is this one here, isn't it? Okay, it's not a very satisfying explanation, but yeah, so in terms of the My iMaths, we've got this. We've got f of x is going to f of minus x, which is a reflection in the y-axis. And it works for all functions, not just for sine function, but for all functions. Okay, the last one, nearly there guys, the last one we're going to look at is reflection in the x-axis. Okay, so play around with this, see if you can figure out why it's happening. Look at the function here, see how it changes as we reflect in the x-axis. Pause the video until you can explain that in your own words. This function would simplify to g of x equals minus sine of x. So all we're doing, if we consider f of x equals to be sine x, this is f of x goes to minus f of x. Okay, whoops, I used the wrong sign there. That should be a minus sign in there. Okay, so this was f of x is transformed into minus f of x. This reflects in the x-axis. Now the reason that happens is because